Alright, 8th graders, today we're going to talk about factoring. And so all factoring means is that we're going to do the opposite of multiplying polynomials. So factoring is the opposite of foiling. Our essential question is, can you factor a trinomial x squared plus bx plus c into the product of two binomials? So notice this is the product of two binomials because there are two terms in each set of parentheses. And product just means to multiply here. So we're undoing multiplying binomials or multiplying polynomials. To factor a trinomial, you have to figure out what multiplies together to make your C value and what adds together to make your B value. So really, as long as you have a 1 in front of the x squared, which today we're only going to have a 1 in front of the x squared term, we're looking to see what adds to make B and also what multiplies to make C. And those two things are going to go in these two spots right here. So whatever two numbers add to make B and multiply to make C go into your binomial sets of equations in that spot right there. So the first thing that we have to do, or the easiest way to go about solving these problems, is to look at the C term. So this is B, this is C. We want to know what multiplies to make C and adds to make B. So the easiest thing to do is list all of the things that multiply to make 16. So 1 times 16, 2 times 8, 4 times 4. And then once we have our list of things that multiply to make 16, we can see what pair adds up to make, in this case, our B value is 10. So 2 and 8 is our answer. So we write our answer as x plus 2, x plus 8. And we can check our work to make sure that we're right by foiling. So first, outer, inner, last. And when we combine like terms, we get x squared plus 10x plus 16, which is the same as our problem. So we know that this answer is correct. You can always check your work by foiling, and good news, doesn't take that long. So checking your work should become part of your daily routine. On the next one, we have to figure out what multiplies together to make 1. Well, 1 times 1, right? And lucky enough, 1 plus 1 is 2, so adds to 2, multiplies to 1. We write our answer as x plus 1 times x plus 1. And again, we're going to foil so that we can check our work. X times x is x squared. X times 1 is 1x. 1 times x is 1x. 1 times 1 is 1. So we get x squared plus 2x plus 1, which is our problem. So we know that this is correct. On the next one, we have 8, so 1 times 8, 2 times 4, but we can quickly see that only 1 times 8 adds up to 9, so x plus 1, x plus 8, and again, if we FOIL, x times x is x squared, plus 8x, plus 1x, plus 8. We get x squared plus 9x plus 8, which is our original problem. So this product of two binomials is correct. And then on this one we have 1 and 24, 2 and 12, 3 and 8, 4 and 6 to choose from. And which of those combines to make 11? Well, this is 25, 14, here we are with 11, so here we have z's. It doesn't make any difference what you write. In fact, I often just do x, because that's just how my brain's programmed to write them. You wouldn't get taken off for that. Just recognize that whatever the letter, doesn't matter, as long as you get the correct answer. So here we have x times x is x squared plus 8x plus 3x plus 24. So we have x squared plus 11x plus 24, which is correct here. So this is my final answer. Alright, moving on to the bottom row, there are some different things happening here. Up here we had all plus, 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 plus. So that was keeping life much simpler. Down here you'll notice we have a negative and a positive. So in order to get that negative in there and the positive over here, we have to consider, how am I going to get a positive when I multiply but a negative when I add? Well, the only way to get a negative when you add but also a positive when you multiply is if you have both negatives. So negative 1, negative 12 would make negative 13 when you add, but positive 12 when you multiply. Negative 2, negative 6. So here we have positive 12 when we multiply, but negative 8 when we add. So that's our answer, x minus 2, x minus 6. Now, a way to do a quick check to make sure that you're correct is to say, okay, what do these two things add to? Negative 2 plus negative 6 equals negative 8. So there's that. And then what do these two things multiply to? Negative 2 times negative 6 equals positive 12. So there's that. So I know that this is correct. Let's take a look at the next one. Again, we have a negative when we're adding and a positive when we multiply. So that would be negative 1 times negative 3. We got x minus 1 times x minus 3. When I add them, negative 1 and negative 3 make negative 4. When I multiply them, negative 1 times negative 3 makes positive 3. So this is my correct answer. On the next one, negative when we add, positive when we multiply, so both negatives again. Negative 1 and negative 35, negative 5, negative 7, negative 5 and negative 7 add up to negative 12. So x minus 5, x minus 7. They add up to negative 12. They multiply to positive 35. And then the last one, add to a negative, multiply to a positive. So negative 1 and negative 24, negative 2, negative 12, negative 3, negative 8, negative 4, negative 6. If you could see that this was going to be your answer right when you wrote it, that's fine. You don't have to keep going and listing all of your factors. But x minus 2, x minus 12 is your product of binomials. Alright, and the last row on this page now has one more thing that's different. It has a positive here and a negative here. So if I'm multiplying to get a negative, one factor must be negative. Alright, so this gives us lots of options. But again, if you know your multiplication tables well, this won't be so bad. So I list all of the factors, just positive, positive, and then kind of talk through them to myself. So 1, 21, 3 and 7, I think that's it. So now I'm trying to get positive 4. So if I have negative 1, positive 21, I get 20. If I have 1 and negative 21, I get negative 20. If I have positive 3 and negative 7, I get negative 4. If I have negative 3, positive 7, I get positive 4. So my answer is x minus 3, x plus 7. And again, I'm checking, do negative 3 and positive 7 add up to 4? Yes. Do they multiply to negative 21? Yes. So this is my final answer. You can, however, write out each of the options. So, for example, you could do 1 and 15, 1, negative 15, negative 3 and 5, 3 and negative 5. So you are totally able to write out each option. I just, of course, prefer to write less than that, so I generally leave the 1 and 15 and the 3 and the 5 without signs and then kind of imagine where they might go. So to get a positive 2, I would need my 5 and negative 3. So I get x minus 3, x plus 5. One thing that you can do, it's not incorrect, if you have x plus 5 and x minus 3, it's still correct no matter which way you have these, because we know that multiplication property can be in any order. Alright, on to the next one. 30 would be 1 and 30, 2 and 15, 3 and 10, 5 and 6. And so one of them has to be negative to get the multiplication piece to be negative, but I need a positive 13 when I add. So at first I would go to 3 and 10, but those would both have to be positive or negative to get 13. So then I move to 2 and 15. And if the 2 is negative, then my answer, y minus 2, y plus 15, would work, because when I add them I get 13, when I multiply them I get negative 30. And now for the last one, I have negative 40, so 1 and 40, 2 and 20, 4 and 10, 5 and 8. And which combination of those would get negative 3 when I add? Well, if I put the negative on the 8, I would get negative 3. So x plus 5, x minus 8. And we want to check, when we add we get negative 3, when we multiply we get negative 40, so we're all good there. On the back page, I'm going to let you try 1 through 6 on your own. I would like to do 7, 8, and 9 with you though. So on 7 and 8, you have equations, and equations are solved the exact same way. So we're looking for what multiplies to positive 33 adds to negative 14. So that means I have to have a negative times a negative to get a positive, so I can get negatives here. So 1 and 33, 3 and 11, and they're all going to be negatives. So we get negative 3, negative 11. So in this case, x minus 3, x minus 11 equals 0. So I want to know when each of these things equals 0. Now, we know that when we multiply to equal 0, either this has to equal 0 or this has to equal 0. One of the two has to be 0 to get 0 when we multiply. So for this to be 0, what would I fill in for x? I would fill in 3 for x. 3 minus 3 is 0. Or here, if I have 11 for x, 11 minus 11 equals 0. So this part would be equal to 0. So 11 minus 3 would be 8. 8 times 0 would be 0. In this way, 3 minus 3 would be 0. 3 minus 11 would be negative 8. So 0 times negative 8 would be 0. So the answer here is x equals 3 or 11 to get 0. On number 8, we'll practice that some more, so don't stress about it. On number 8, we have to have this always equal to 0. So we need to subtract 54 from both sides, and so we get x squared minus 3x minus 54 equals 0. So now we're looking for what multiplies to 54. Negative 54 and adds to negative 3. 6 and 9, I guess 2 and 27, but that's not going to give us 3. So negative 9 and positive 6 will give us our negative 3 here. X plus 6 times x minus 9 equals 0. So what would x have to equal to make this whole thing 0? Negative 6. What would x have to equal here to make this whole thing 0? Positive 9. So on this one, x equals negative 6 or positive 9. On number 9, we have the area in square meters covered by a building can be represented by x squared plus 7x minus 30. Write binomials that represent the length and the width of the building. So we know length times width makes area. And so when we look at this, we need to find length times width. So what do we we need to multiply to get negative 30 and add to get negative 7. So 1 and 30, 2 and 15, 3 and 10, 5 and 6, and we need a negative 30 when we multiply, so one of these has to be negative. If I did negative 1, that'd be 29. If I did negative 2, that would be 13. If I did negative 3, that would be 7. So I get x minus 3, x plus 10. For length and width, find the perimeter of the building when x equals 15. So you have two options. You can put the 15 in for x up here, or you can put the 15 in for x down here. I like to use the factored form because 15 minus 3 is 12, 15 plus 10 is 25. I don't have a calculator handy and this video is long enough, so you guys can figure out what that equals. Don't forget to label. Oh, this isn't perimeter, this is area. JK. You're still using this, length and width, but the length, again, is, we want to do length plus width plus width. So, 15 minus 3 is 12, and 15 plus 10 is 25, and that one I can do easier without a calculator. 50, 62, 74 meters for perimeter. Alright, try those problems at the top of this page, and we will go over them tomorrow. Have a great night.